of this be 20. I given an input signal of say 10 millivolt. So what will be the output here? 1. What will be the final output? 2. So first the signal comes will get inverted. No, it's a C amplifier. This is V1. Now this will get further amplified. So what is A1? A1 is equal to V1 by Vin. So what is V1? A1 15 into 10 to the power of minus 3. 150 millivolt. Now this input will become this output of first stage amplifier will become input for the second stage amplifier. So therefore what is A2? A2 we write V2 by V1. This will become input cascaded. What all signal produced by this, the output of this will become input. I'll feed it here. I'll connect like one by one. So usually what happens, we use multi-stage amplifier. More than at least one will never use any application. 2 stages or 3 stages will be used here, and they'll be carefully designed. Okay, now of course the negative sign should be there. Okay, let me bring that negative sign. Now this negative sign should be there. There's a basic definition. No? Now what is A2? 20. V2 we don't know. What is V1? Minus 150 into 10 to the power of minus 3. I think I'm getting 3 volt. See, like 10 millivolt. You have increased the strength to what? 3 volt. How many times you have increased? From 0.01 you have made it to plus 3. I think it's a very huge change, no? You can now, if this signal, if it is given to loudspeaker, you can hear clearly. Now, in a class, no, what I speak will be of this. Hardly, I think, without mic, first and second bench at the most, or third bench. Now, with amplifier, adjacent class also can hear me. Who has increased the loudness? The amplifier here. How? Amplifier will not do anything to sound signal. The mic will convert the sound to AC signal. They'll be given to amplifier. The amplifier will increase the amplitude of the signal. Hind will be given to loudspeaker. Higher strength signal given to loudspeaker, more loudness. Finish short. Like this, these are called loudspeakers. At least now, okay, loudspeaker means. Now, from where this energy has come? Anybody? From where this energy has come? Let's go back. From where this amplifier energy circuit will come? The DC source, no? So what amplifier is basically, it will convert DC signal to AC signal. The DC energy is converted into AC energy. That's what the amplifier is doing here. Okay, now, sir, one more thing. If you look at the incentive book, no, one more year has gone. If I plot this V out versus V in graph, there's one more very good graph is there. The graph takes shape like this. Output voltage, and what is this? This is input voltage. When I plot the output voltage versus input voltage, I'm getting a graph of this kind. What do you mean by this? Okay, then what is the voltage gain ratio of that? So where the gain will be maximum? Where I plot this one. So here, this what I'm getting curve. So you look at the slope here. The slope is maximum here, no? I think some again the curve. So the slope is maximum in this region. The slope is maximum here. What about slope here less? Again, the slope is less here. So therefore, what is this? This region will become the active region. So how do you can say it's a active or how do you can say it's an active or cutoff? Okay, come back. What is V naught? V naught is nothing but VC, you know, try to correlate things. Am I right? Say what all we put everything, there's a reason. Okay, now go back morning class. If VC is more, then what it is? It is said to be cut off, no? So how can you correlate so many things here? So again, recollect the graph, what we have. The graph was like this, no? Tell me like a, what I shown this. This is what cutoff, no? I don't know, some colors I gave. This what cutoff. Then I shown this is some sort of like a. Don't draw a rectangle. Some inclination should be there. I think this what saturation. No, and this is what the active. Huh? Now shall we? What is VC? Okay, look at this one. If VC is more, it should be cut off, no? If VC is more, it should be cut off. I think slope should come. Yeah, let's take this one. No, if VC is more, it should be cut off. This is called a cut off. Okay, now you say like there's a cut off region. Then where if VC is less, there's a saturation region. So therefore, what is this particular point? This will correspond for cutoff. This particular point correspond for saturation, and this particular point cut off for active. Now look at the slope. Where slope is maximum, check it. Slope is maximum here, no? And it's negative. That's why, okay, we got it. You can do like this also when you plot VO versus VIN. So what is VIN? For different voltages, as you keep on increasing. Again, don't make this 5 volt, but not possible. We don't get that much of input voltage. When you increase input voltage, say like a 1 millivolt, 2 millivolt, 3 millivolt, 5 millivolt, no? Then corresponding plot the output voltage. The curve will be like this. Then here the gain is maximum. So where the gain is maximum? At point 2. Gain is maximum. So therefore, I'm going to use at this particular point, and it is an active region. Sir, how you can see it's active region? We know in active region what is VC should be off of the maximum value permitted VCC. Okay, go this. Look at this point. It is off of, no. This is the maximum permitted value of VC. Will be off of it. So therefore, this is active region. They may ask you a graph of this kind. It's not an NCERT book, but some related CBSE books he has discussed here, or you refer any semiconductor devices, no? Like we discussed this one. This most important graph. Why do that native sign? Why we preferred active region? Because here the gain is small. That's why the active region I picked up. Now, what is the basic condition? In active region only, the gain is maximum. Agree this? I had to justify, no. See, like an active region is something very important. In active region only, the gain is maximum. So therefore, to have that active region, what I should do for transistor? The collector base junction should be reverse biased and base emitter junction should be forward biased. There's the one thing, okay, fine. Then to have the more gain, the gain should be more, no? So tell me what I should do. Beta should be more. For beta to be more, IB should be less. For IB to be less, what happened? The base should be lightly doped and collector should be more like a moderately doped, means the base emitter junction or the collector base junction should penetrate more into the base, no? Because the base will become thin, then IB will become less, beta will be more. So therefore, the width of collector base junction should be more than the width of base emitter junction. Then only the beta will be more. The instead of width, they called area. I think somebody today like just sent me that one. The width, why the collector base junction will have more width when it's reverse bias means because the base is more lightly doped. So therefore, as the base emitter junction is forward bias, collector base junction is reverse bias. So the reverse bias will have more width, no? Depletion layer will be more. And base emitter is forward bias, the depletion will be thin. So therefore, the area of the depletion layer of the collector base junction will be more than that of the base emitter junction. It should not call area width. There's a language problem. Please do correct. So if width of depletion layer of collector bridge junction is more, means IB will be less, beta will be more, then gain will be more. So for the amplifier, what happen? What are the preferences I should make it? The base should be lightly doped, emitter should be heavily doped, and collector should be moderate doped. With this, what we get? We get higher beta. Higher beta, more gain. And the what should be a transistor? Transistor should be operated in where? In active region. So these are all things what we have here. Okay, this I'll show one problem, then I'll stop the class. One problem will take it so that you will understand.